All right, guys, today is the big day. You are starting the last unit of Math 1, Math 2. So this is going to be our probability unit, and it's going to take us through the end of the year. So today, we're not actually calculating any probabilities. All we're going to be doing is describing sample spaces and events. So you're going to start learning some probability notation and some of the other things that you're going to be using as this week and next week progress. So you're going to want to be on page 252 in your Walsh book. So first thing we have here is we have a table that gives us some information about these students here. And it is basically saying a student is chosen from the group at random, list the sample space, then describe each of the following events in terms of the student's activities. So an event is like something that occurs. So, like an event is like the result of some sort of statement. So, when we look here, we're going to go ahead and start with just what is the sample space. So, the sample space is the set of all possible outcomes. So, when we are looking at the sample space here, we want to list out all the possible outcomes. So the outcomes here, looking at the different events that are possible. So the outcomes are all the different things that could be listed as the result of an event. So these are different outcomes. So all the possible outcomes are all of the possible people. So here, when I go to list all of the outcomes, I just have to list every single one of these people. So that's going to be Asher, Ray, and we put them in brackets. Eva, Merida, Isabel, Ben, and Nate. So we know that that right there are all of our possible outcomes. Now, the next thing that we're going to do is we are going to analyze this first outcome here. So when we are thinking about some probability words in terms of outcomes, the words that we would use are is, not, and or are all important words when we are describing events. So the first outcome we're looking at is Ava and Nate. So what we want to do is we want to look up here and we want to figure out what is true about Ava and Nate. Well, Ava is in debate club and German club, and Nate is in chess club and German club. So I want to be able to write a statement that is only going to give the results of Ava and Nate. It can't give any other results, only Ava and Nate. So if I look here, if I said the student is in debate club, well, that wouldn't work because only Ava's in debate club. And if I said the student is in chess club, that won't work because only Nate's there. But if I look here, if I state that the student is in German club, there are only 2 students in German club, and those 2 students are Ava and Nate. So when I come here, the event that would produce this result here is the student is in German club. All right, so the next thing that we're going to look at is we're going to look at the event where it would only be Isabel. So when we look at her, she is in debate club and she's also in band. So if we say the student is in debate club, well, that would not just be the result of Isabel, that would be Isabel and Ava. So it can't be that. And if we say the student is in band, then it could be Isabel, Merida, or Asher. So we can't say that. But if we look, we do know that Isabel is the only student who is in both debate club and band. So the statement that would produce Isabel is the student is in the debate club and the band. So again, you have to create some sort of statement that could only produce the given outcomes or the given events. So it says describe the event that produces the outcome Ben, Nate, and Ava. So if I look here, we're looking at Ben, Nate, and Ava. So Ben, chess club, Nate, chess club, Ava, debate, and German club. So we can't use and here because there's nothing that all three of them share. So we can't say they're in like chess club and debate club or they're in chess club and German club because they don't all three share something. So I want to think about whether or not I could use or. So when I go to look here, let's figure out what are some options here. So if we're thinking about the word or here, again, in this problem, we're talking about Ben. So we're talking about Ben here. We're talking about Nate. And we're talking about Ava here. So we've got chess club, chess club, chess club, debate club, German club. So if we think about chess club here, the only two people in chess club are Ben and Nate. So if I said the student is in chess club, it could only be Ben and Nate. And if I said the student is in German club, it could only be Ava and Nate. So now I'm thinking that I need to be able to include chess club and German club, but it can't be both. So now that's where that word or is. Here it's going to be the student is in chess club or German club, because if you think who's in chess club, only those two, who's in German club, only those two. So the statement, the student is in chess club or debate or German club, is the one that isolates those three. The student is in chess club or German club. Now in the following one, we've still got Ben, Ava, and Nate, but we're also adding in Ray now. So let's add in Ray. Well, Ray is not in anything. Okay, so we're now talking about Ray here. So let's try to figure out if there's something that they have in common. Well, there isn't anything they have in common because Ray doesn't do anything. So let's think about everything else. So Asher's in band, Merida's in band, Isabel's in band. So the three people that I don't want are all in band and nobody else is in band. So if I want to be able to produce one of these four people, I can say the student is not in band because the only students that are not in band are those four right there. So for number 5 here, it would be the student is not in band. So I know that that might be a little bit complicated, but it is not in band. But you can handle that. You just have to start thinking about what are the options and then how do you only isolate that specific event there. So the next thing that we're going to look at is actually going to start getting us into some different symbols that we're going to be using here. So we have these letters here that each one of these letters represents the animal that we're talking about there. And then each one of here, we have some symbols that are going to help us figure out what it is asking for. So in the first question here, it's asking us to list the outcomes of C. So if it wants us to list the outcomes of C, it's just asking us what are all of the things that could be C. So it's asking us who are all the students that have a cat. So the outcomes for C are going to be student 2, student 7, student 9, and student 10, because that means all students who have a cat. All right, so the next one that it's going to ask you for here is D, and then this symbol here is the intersection of. So again, that means intersection of. and it means and. So it wants the intersection of students who have a dog and students who have a bird. So it's asking you what students have a dog and a bird. So we're gonna, and you should be looking at your book here, and I'm looking at mine. I'm not gonna keep scrolling back up to that table. So if you want to know D intersecting with B, you want to know which is the students who have a dog and a bird. So when you look at your table, you go to where the dog is. You see that student 2 has a dog but not a bird. Student 4 has a dog but not a bird. Student 7 has a dog and a bird. And that's it. So the only one that would fit that outcome there is student 7. So that symbol there means and. So this means dog and bird. Now, the next one here is asking us H or F. So this symbol here means the union of, and it means or. So here it's asking us how many students have a hamster or a fish. So here I just need to go down each row and I just need to figure out who has a hamster, then who has a fish. Well, student 5 has a hamster and student 5 also has a fish, but I don't need to list that student again. And then student 6 also has a fish. So that is the only one that is the union of a hamster and fish where they have both. All right, so in the next one here, you have a new symbol here, and the line above the letter basically means not. So here it's saying not bird. So this is saying who doesn't have a bird. So again, the line is always going to mean not. So who doesn't have a bird here is going to be all the students without a bird. So that's every student except for 7 and 9. So that's 1, 2, 3, 4, 5, 6, 8, and 10. And those are the students who do not have a bird. Well, now this says D and C. And the way that I remember that this one is and is that I just imagine like that I read the letter or I wrote the word and that's like the little N in and. So D and C, but then so that would mean dog and cat, but this would mean not. So this is saying who does not have a dog and a cat. So if you want to know who does not have a dog and a cat, oops, that should be a C. Well, the only people that have a dog and a cat are 2, 7, and 10. So that would be everyone except for 2, 7, and 10. So that would be 1, 3, 4, 5, 6, 8, and 9, because those are all the people that don't have a dog and a cat. Now the next one is similar. This would mean dog or a cat. So this wants to know who does not have a dog or a cat. And again, this notation is super important because right now you're just learning the notation and soon we're going to be using it. So who does not have a dog or a cat? Well, I go here. Student number 1 does not have either. Student number 3 does not have either. Students 5 and 6 do not have either. And student 8 does not have either. So those are the ones that do not have a dog or a cat. So I hope that explanation of those symbols are helpful there. Please come back and make sure that you've taken notes there. Make sure that you wrote down that this symbol here means and, that this symbol here means or, that this symbol here means not. That's stuff you have to know. All right, so now we're going to move on to example 3. And in example 3, we are going to be creating a Venn diagram here. So it says Hector's entered the following names in the contact list of his cell phone: Alicia, Brisa, Steve, Don, and Ellis. And he chooses one of the names at random to call, and we're supposed to consider the events. B, the name begins with a vowel. E, the name ends with a vowel. So it says draw a Venn diagram to show the sample space in the events B and E, then describe each of the following events by listing the outcomes. So it says draw a Venn diagram, use a rectangle for the sample space, use circles or elliptical shapes for the events B and E. So it's basically just saying create a Venn diagram here. And then it says to use a rectangle for the sample space, and you'll see why that's important in a second. And here we go. So it says that one of ours, so they're supposed to be B and E. And then in the middle here would be both, so that would be B and E, or B intersecting with E, beginning and ends. So let's go ahead and deal with these people. The first one is Alicia. Well, her name begins and ends with a vowel. So it goes here, Alicia. Then we've got Brisa. Well, her name ends with a vowel. Then we have Steve. His name ends with a vowel. Then we have Don. His does not begin or end with a vowel, so his goes out here. And then we have Ellis, whose name begins with a vowel, so Ellis goes right there. So that is what your Venn diagram should look like when it's completed. And again, the whole thing there is the sample space. All right, now using this Venn diagram, the sample space, it should be pretty easy to answer our questions. So the first one wants to know the outcomes of B. So whose here begins with a vowel? Well, remember, when you're looking at B here, this whole thing is B. It is both B and E. So the outcome for begins with a vowel would be Ellis and Alicia. I think I maybe just changed how I said her name in the middle of this. All right, E is going to be list the outcomes of E. So that's going to be the names that end with a vowel. So there we're still going to have Alicia, but we're going to add Steve and Brisa. So again, E just means ends with vowel. B just means begins with vowel. Well, this one wants the outcome of B intersecting with E, so that means B and E, so this is begins and ends. So if we want begins and ends, we are looking in the center of our Venn diagram, and that is going to give us just one, and that is Alicia. Now here, this one is begins or ends. So again, begins or ends or both there, because that means if it's both, it does begin with it or it does end with it. So this would be B or E. So this would be Ellis, Alicia, Brisa, and Steve. Then here, this one means list the outcome of not B. So this means does not begin with a vowel. So not B here is going to be everyone except for the ones that begin. So that's going to be Brisa, Steve, and Dawn. Then finally, this is B or E, or both. So this is which one who does not begin or end with a vowel. So now we're looking for people whose names do not begin or end with a vowel. And that's only one person, and that's our friend Dawn there, who is outside of the Venn diagram, but still inside of the sample space because he is not either or and the things that we're talking about there. So I hope that that is helpful there. And now we're going to move on to the next one. So we're getting close to the end here. So one thing that I'm going to recommend that you do right now is we are about to deal with a sample space where we're talking about flipping a coin 3 times. And this is going to be a sample space that we use over and over again during this unit. So if you want to create like a nice one that you use several times, you can do that. But this is something that you're going to want to have access to over and over again. It also doesn't take this long to make this one, but it is important. So it says an experiment consists of tossing a coin 3 times. Consider the following events. A says the first toss is heads. B says the second toss is heads. C says 2 consecutive heads. D, there are 2 consecutive tails. E, the first toss is heads and the second toss is heads. And F, there are neither 2 consecutive heads nor 2 consecutive tails. So it says list the sample space, then express E and F in terms of the other events and list the outcomes of E and F. So when we're looking here, E is telling us that the first toss is heads. Well, the first toss is heads is actually A right there. So that is outcome A. That's what the first toss is heads means, is outcome A. So the next thing is it says and. So we know that in probability language, and is the intersection. So it's that symbol there. And then the second tosses heads is B. So what this is really asking us for, E is really asking us for the union of A and B. It wants to know when is the first toss heads and the second toss heads. Hope that makes sense there. So again, E is in terms of A and B there. Now here, the third one, or C here says there are 2 consecutive heads. D says there are 2 consecutive tails. Well, this says there are neither 2 consecutive heads nor 2 consecutive tails. So basically, we don't want D to happen, and we don't want C to happen because 2 consecutive heads would be C. So I want not C to happen, nor or. So or is that, or I don't want 2 tails. So I also don't want D to happen. So I don't want C or I don't want D. So F is actually saying not C or D. So that's what it means when it says express E in terms of the other events. So now we're going to have to figure out which trails in the sample space here would fit event E and event F. So sample space here when you're flipping a coin. So the way that you start this is you basically start at a starting point. You're going to make a tree diagram. So imagine that you flip this coin here. Well, there's a couple options of what can happen. One option can happen is that the coin lands what? Well, we should know that one option, oh, this is going to be annoying, is that the coin, oh, why must it do that? Is that the coin lands on its tails. The other option is that the coin lands on its heads. So this right here is the first coin toss. On the first coin toss, it could be heads or tails. Well, now we're going to move on to the second coin toss. Well, on the second coin toss, it's possible that the first toss was heads and then the second toss was heads, but it's also possible that the first toss was heads and now the second toss is tails. So at the same time, it's possible that the first toss was tails, and now the second toss is heads, and it's possible that the first toss was tails, and the second toss is tails. So right now, this was your first coin. Now you've got your second coin. So if you only flip 2 coins, there are 4 possible options: heads, 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 tails, tails, then heads, or tails, then tails. But the thing is that we are going to flip a third coin here. So it could be, I could flip the first coin and it's heads. I flip the second coin and it's heads. That third coin could be heads again. Or I could flip 2 heads and then all of a sudden I could flip a tails. Or I could flip a heads, then my second was a tails, but then again, my third could be a heads, or my third could be a tails. Then again, I could have started with a tails, then gotten a heads, and then gotten another heads, or I could have gotten a tails and a heads and then another tails. Or my final option is that I got a tails, and then I got yet another tails, or tails, tails, and then I got a heads. So again, by the time I flip that third coin there are actually 1, 2, 3, 4, 5, 6, 7, 8 different ways that I could create or 8 ways that I could, 8 outcomes, 8 possible ways that this could happen. So the first thing that it wants is E, which is that A happens and B happens. So when I go to list E, I have to think about my pathways where A happens and B happens. Well, A says that the first toss is heads. So the only ones that could be A are these 4 options up here, because the first toss is heads, it's only these 4 up here. So I need the first toss to be heads, and I need the second toss to be heads. So it's got to be this one and then this one. Well, this means there are still 1, 2 options. So for the first toss to be heads and the second toss to be heads, there's actually 2 potential outcomes: heads, 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 and heads, heads, tails. There's no other pathway on here where you first get 2 heads. So again, the way you would list that is heads, 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 and heads, heads, tails. Now for the next one here, we're supposed to be dealing with outcome F, which is C, neither C or D. So C says there are 2 consecutive heads. So I need to find out where there are not 2 consecutive heads. So one option is, well, this won't work because these are 2 consecutive heads either way. But this one, heads, tails, heads, is not 2 consecutive heads. So it's possible that it's heads, tails, heads. It's possible that it's heads, tails, tails, because that doesn't have 2 consecutive heads. It's also possible that it's tails, heads, tails. And then it's also possible that it is tails, 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 or tails, tails, heads, because none of those have 2 consecutive heads as you look through it. But here it also says you cannot have 2 consecutive tails either. So if I go look at these choices, well, that's 2 tails in a row. That is 2 tails in a row. And that is 2 tails in a row. So if I'm going for my outcomes for F here, where I have neither 2 heads and a tail nor 2 tails, or neither 2 consecutive heads nor 2 consecutive tails, I only have heads, tails, heads, and tails, heads, tails, which I guess I wrote down wrong one of the times. Sorry. But again, you've got heads, tails, heads, and tails, heads, tails. That is all you've got that don't have a consecutive for either. All right, so the last one here is going to be slightly more frustrating because we have a sample space that is very large. And I recommend that you just write the sample space down in pen somewhere, maybe use a Sharpie just so that you can come back to it multiple times, because we are going to have a sample space for rolling a pair of dice. And when you're rolling a pair of dice, you have a situation where there's going to be 36 possible outcomes because you could roll, oh, if my pen makes me redo this every time, a 1 and then a 1, or you could roll a 1 and then a 2, or a 1 and then a 3, or a 1 and then a 4, and so on and so forth here. But I also could have rolled a 2 and then a 1, and a 2 and then a 2, and a 2 and then a 3. So I'm going to pause the video, but I want you to keep making that chart, and then when it'll all be made when it comes back. All right, here. So that is the full sample space for when you roll a pair of dice. So it says how many ways can you roll the dice so that the product of the two numbers is less than their sum. So it wants you to investigate how many ways how many ways is it true that when you multiply them, what you get is less than their sum? Well, 1 times 1 is 1, and 1 plus 1 is 2, so that works. 2 times 1 is 1, but 2 plus 1 is 3, that works. 3 times 1 is 3, 3 plus 1 is 4. So you're going to recognize that all of these ones that pair the number with 1 are going to work because when you multiply them, it stays the same, but when you add them, it gets 1 bigger. So it's going to be all these ones down here. Well, here, when we add these, we get 4. When we multiply them, we get 4, so that doesn't fit the rule. When we add these, we get 5. When we multiply them, we get 6, and that's only going to increase here. And so these are the only ones where that is going to be the case. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different outcomes. Because it just asks how many, doesn't ask you to list the outcomes, it just wants to know the number of them. So I hope that was a good crash course to probability. Tomorrow during our Zoom class at, maybe not tomorrow. Yes, tomorrow, because it'll be Wednesday. So tomorrow during our Zoom class at 3 p.m., we are going to check the homework. So for the homework, you want to go ahead and look at the assignment. So it starts on page 56, and then it goes to page 258. So again, starts on page 256, goes to 258. For number 6, when you're looking at, after number 6, when you're looking at that spinner there, I don't want anyone to get confused. Close your eyes. Don't see how unorganized that is. Okay. So if you're confused about that one, again, when they start to ask you any sort of question, you have to list the sample space. So if we're looking at this problem here, it gives you a spinner that's divided into A, B, and C. And then it has, it's a spinner. And it's basically saying you spin it 2 times and then you answer the question. Well, basically, when you create the sample space, you could get A and then A, you could get A and then B, you could get A and then C, you could get B and then A, B and then B, blah, 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 blah. So there are 9 total things you could get there, so I hope that helps. But again, you can't start answering any of these questions until you know what the sample space is. So again, please do not start answering until you know what the sample space is. Please do not start answering until you know what the sample space is. So again, that should be helpful. So homework is page 256 to 258. We'll go over that during Zoom class, and then we will start our next lesson where we actually start calculating some probabilities. All right, talk to y'all later.